When the first tanks rolled onto the battlefield, it seemed that their armor would make them invincible. But the reality was very different. Even the most advanced German machines could be destroyed by surprisingly light infantry weapons. A small anti-tank rifle, hidden in an ambush, could throw tank crews into panic, forcing them to fight desperately for control. Some vehicles were knocked out instantly, even when it seemed that their armor should have protected them, leaving the crew barely a moment to react. Engineers searched for solutions, but each new layer of armor brought its own problems. The tank became heavier, less maneuverable, and the crew more vulnerable. The history of side screens, light shields, and mesh armor is, in many ways, a story of survival, where mistakes were costly and every innovation could be a last chance to stay alive. It shows how tanks that seemed invulnerable faced threats they could not avoid, and how engineers devised clever protective methods that changed the understanding of armor forever. This is a story about fear, ingenuity, and how a single detail could decide the outcome of a battle and the fate of the crew. At the beginning of World War II, tank units faced a problem that soon became critical. Standard armor was no longer enough to protect machines from increasingly powerful enemy weapons. Engineers tried to strengthen armor by increasing the thickness of steel plates, but this approach had limitations. Suspension systems and engines often could not handle the added weight, reducing maneuverability and shortening the tank's operational life. Confronted with this dilemma, designers looked for new ways to protect tanks while maintaining their effectiveness on the battlefield. The first attempts appeared in Poland on the PZ-2, when the Panzerwaffe unexpectedly encountered enemy anti-tank guns. The solution involved fitting thin 20mm armor plates on the front of the hull and turret, spaced slightly away from the main armor, creating a form of spaced protection. This method partially dispersed the energy of incoming fire, though its effectiveness was limited, especially against shots from the side. Despite its limitations, the concept of spaced armor evolved in later vehicles, including the PZ-3, PZ-4, and the Ferdinand self-propelled guns, where reinforced frontal armor helped withstand direct hits, while side armor remained vulnerable. Engineers experimented with varying the thickness of the outer plates, trying to balance protection with the load on the suspension, but soon abandoned this approach. Thin side screens offered minimal stopping power, and the weight remained a concern. In 1942-1943, these screens proved invaluable for crews, even though they remained largely ineffective against more powerful anti-tank artillery. Tests on captured Stug-40 vehicles showed that side armor could be penetrated by 45mm shells at distances close to a kilometer. But during near detonations of explosive shells, the screens provided some protection, reducing damage from shrapnel. Alongside these advantages came drawbacks. On rough terrain, the screens often caught on soil, trees, or obstacles, occasionally tearing off and exposing the vulnerable sections, while their weight placed additional strain on the suspension, reducing tank longevity. From 1943 onward, crews often removed screens themselves, preferring maneuverability over formal protection, highlighting that tank defense required both armor strength and tactical mobility. To reduce weight, mesh side screens were introduced. They offered similar protection to light plates and were easier to install, though they did not significantly improve off-road performance. Despite limitations, the concept of side screens laid the foundation for further development of anti-cumulative armor systems, which emerged after World War II when anti-tank rifles gradually gave way to handheld rocket launchers. Modern screens use the principles established in the 1940s. They deflect shaped charge projectiles with rubber-backed plates or steel meshes, dissipate impact energy, and disrupt the formation of cumulative jets. Their design has evolved. Massive steel plates have been replaced with lighter constructions, while active and reactive protection systems now handle the main defensive role. The history of side screens illustrates the complexity of engineering thought and the need for compromises between protection, mobility, and vehicle longevity. It shows that tank armor is not just about steel thickness, but about evolving defensive methods, responding to new threats, and constantly seeking a balance between strength and mobility. From early experiments with the PZ-2 to modern reactive protection systems, one can trace continuous evolution. Engineers studied projectile behavior, tested different materials and designs, gradually forming the concept of comprehensive protection. Side screens became a crucial element, offering temporary safety to crews, allowing them to continue maneuvering and completing missions, even when direct armor reinforcement was impossible. This history demonstrates that tank development is not only a story of weaponry but also of engineering ingenuity, finding solutions under pressure and in the face of real danger. The effectiveness of these screens depended on combat conditions, enemy types, and specific vehicles, but their introduction allowed German crews to adapt to new challenges and maintain operational units on the front line. Principles established with lightweight and mesh screens were refined post-war as anti-tank rocket launchers and artillery became more powerful and versatile. Experiments with materials and forms, along with integration into dynamic protection systems, made modern armor far more effective than in World War II. Thus, the evolution of screens reflects not only technical progress but also continuous adaptation to the changing battlefield. Engineers sought ways to protect crews, preserve vehicles, and maintain maneuverability, making armor a key part of tactical strategy. Every detail, whether a light mesh or a complex reactive system, is the result of years of research and field testing, where each mistake was a lesson and every success a step toward modern protective methods. Today, tank designs incorporate accumulated experience, from precise calculations of armor thickness and screen placement to the integration of dynamic systems capable of countering diverse threats. Though anti-tank rifles disappeared almost immediately after the introduction of rocket launchers, the concept of screens survived and continues in new forms, protecting crews and vehicles. The story of side screens is one of adaptation, ingenuity, and continuous evolution of tank armor, now combining solid steel, dynamic elements, and carefully designed structures capable of countering modern threats while preserving principles established over 80 years ago. Each innovation, from light mesh to advanced reactive systems, follows the path begun by Panzer engineers and shows that tank protection evolves alongside the weapons it is meant to counter. From early Panzer II experiments to today's combat vehicles, a single continuous line can be traced, balancing weight, protection, and mobility, preserving the crew and vehicle while adapting to changing enemy tactics. Modern protective systems are the result of years of experiments, field tests, and damage analysis, proving that engineering thought can respond to real threats and keep tanks operational on the battlefield.